Hello everyone. Now we're going to be starting off with our next topic, which is pandas. So let me just start off. Yes. So everyone, right now we have completed NumPy and now we're going to be looking at pandas. So everyone, pandas is another powerful library in Python, which is designed for data manipulation as well as analysis. So it provides easy to use data structures and functionalities for effectively handling as well as analyzing structured data. Now let's delve into these key features of Panda. So the first feature of Pandas is series and data frames. So about series, okay, so data structures are nothing but a structure of the data in which the data can be stored. Okay, so there are inbuilt data structures and there are user-defined data structures in Python, but in Pandas you have series and data frames. So what is a series? A series is a one-dimensional labeled array capable of holding any data type. And each element in a series has an associated label or an index number. It is very similar to a column in a spreadsheet or a single column in a database table. We also have data frames. Now, what is data frame? Data frame is a two-dimensional labeled data structure with columns that can be of different data types. It is going to resemble a spreadsheet or even an SQL table. It is going to allow manipulation as well as analysis of the data in a tabular format. Next, we have label-based indexing, meaning that Panda library, it provides a very powerful indexing capabilities that allows you to access data using labels instead of numerical indices. Labels can be specified during the creation of these series as well as data frame, providing a more intuitive and a very flexible way to refer to a data. And like for example, you can refer to a particular column like age, and you can refer to a particular name inside that age category. Okay, we will look further what is label based indexing. There is also data alignment. So pandas automatically aligns data based on labels. So with this makes it easy to work with as well as combine data sets. So when performing operations between series or data frames, Panda aligns the database on the labels, finding in missing values wherever it is necessary. Next up, we have extensive data manipulation capabilities. So, Panda offers a wide range of functions and methods for data manipulation. For example, it offers filtering and selection, meaning that you can selecting specific rows or columns based on conditions. You can sort data based on values or indices. You can group data based on certain criteria and even perform operations on each group. And we can also combine multiple data frames into a single data frame based on common columns or even indices. And lastly, you can change the layout or the structure of the data. Now, let's understand what is series and data frame in pandas. So, starting off with series. So, a panda series is a one-dimensional labeled array that is going to help you hold data of any data type. Okay, like integers, float, string, boolean value, etc. Or it can also hold complex Python objects. Also, it is very similar to spreadsheets or SQL table, meaning that a Panda series can be considered similar to a column in a spreadsheet or even a single column of data in a SQL table. So it represents a single column of data. And each element in a series has a unique label which is known as index. So this index is going to help you follow for efficient as well as easy access to data points within that series. We also have data frame. Now, so a pandas data frame is a two-dimensional label data structure, okay, and it can hold data of different types like series. And a pandas data frame is going to closely resemble to a spreadsheet of an SQL table, okay. It is going to consist of rows and columns where each column can be considered as a pandas series. Also, a data frame consists of rows and columns. Okay, each row is going to represent a record or observation, and each column represents a field or a variable. So columns can have different data type, allowing for flexibility in handling diverse type of data. So let's understand the differences between them. So now we've understood what both are. Okay, so the differences between series and data frame. So series is one dimensional and data frame is two dimensional. And series is going to usually be one single column. Okay, it is going to have a row label and a column value. But whereas data frames are collections of series objects. Also, you can create series using pandas dot series constructor. Okay, or what you can do is you can create data frame using pandas dot data frame constructor. And about indexing, each element has an index in series, but in data frame it's going to have rows as well as column indices. Now about operations are typically element wise in series, whereas because data frame is two dimensional, which has rows and columns, it has both a row index as well as a column index. And here the operations are element wise, whereas the operations in data frame, they allow for more complex operation, allowing multiple columns. And lastly, the functionality of series is that they are mostly suitable for tabular data and will provide functionality. Next up, we have yes. So everyone, now we have Panda series and data frame, and we are going to go through a few different, codes to understand Pandas library. Also, we will see how you can create a series, how you can create data frames, and how you can access as well as modify them. Okay, so let me share with you the first file. Let me just quickly share my screen. Yes. So the first program that we're going to be looking at is Pandas series. Okay, we're going to be starting off with Pandas series, and then later on we will move ahead with data frames and then accessing and modifying files. So now we have understood, okay, let's break down this entire code. Now we have understood that to use pandas, firstly, you need to import pandas library, okay? So to import pandas library, you're going to use a keyword which is called as import, okay? And then after that, you're going to import the library that you want to work with. After that, we are going to give it the alias PD. Okay, it just makes it easier for you to refer to the library name in your entire script or your program. Next up, what we're going to do is we are going to create a list. Okay, you can see here we have created a list, and after creating this list, the name of my variable that is going to hold this list is called as data. We're going to give this assigning operator, which is an equal symbol, and we're going to assign this list to the variable name data. After that, what we're going to do is we're going to create a panda series. The name of, so how do we know we're creating a panda series is because we're using a constructor dot series. Okay, and then in this, so a panda series is created using this line where we have created a variable series, then we have given an equal symbol, created a panda series using pd dot series, and then we're going to pass a list of integers, which is 1 2 3 4 5, which is saved in data. Okay, now this series that we have just created is a one-dimensional labeled array. Okay, this is one dimensional. After that, what we are going to do is we are going to print this statement, which is original series. And then after that, we are going to print this variable series. Okay, so let's run this code and see the output. So you can see here, this is our first print statement, which is original series. And then after that, we have this output here, which is 0 to 5. Okay, so here you can see that a series has been printed. Okay, so firstly here we are going to print the original series. Okay, and then after that, what we're going to do is we have just created a space here. Now you can see that this is our series, which is 0 to 4. Okay, this is the indices, and then here we have what we also have is 1, 2, 3, 4, 5. If you want to change the input, you can do that. Next, after that, what we are going to do is we are going to access a few elements in your series. Okay, how are you going to do that? Using a square bracket. So what you can do is whenever you want to access a specific element, just like a list or a tuple, you can just give the index number using the square bracket. So in the square bracket, I have given 2. Always remember that the index number, okay, starts from 0, right? Starts from 0. Starts from 0. So now when I say it starts from 0, so this is going to be 0, 1, and 2. So at 2, we have 3. So the output for this particular statement, element at index 2 should be 3. So you can see here that element at index 2 is 3. Next up, we have, here you can see, Uh, after this, we are going to perform operations on the series, meaning that we are going to find the square of our data series that we have just passed here, meaning that you can see we have created a new variable which is called, and also everyone, this backslash n that is written here, this is going to create a new line. Okay, it's just going to create a new line. It is just for readability purpose in your output or your console. So you can see here in the next step, what we're going to do, each element of our original series, which is series, we are going to square, we're going to square them. And then after squaring them, we're going to save it inside this particular variable, which is called a squared series. So then the squared series is printed here. So let's look at the output. You can see here that the squared series output, the first output is 1, then 4, 9, 16, and 25. Also, it is going to mention what data type it is. This is of the data type integer. Next, after that, what we have done here is where you're going to filter the elements. Okay, so what we can do is we can actually contain only the elements based on a specific condition. You can create a series. Okay, so let's say you want to create a filtered series. Okay, this particular filtered series is going to use your original series, but it is going to add a condition. Like for example, here I want the elements of the series that are only greater than 2. Okay, so whatever is greater than 2 is going to be stored inside this variable, which is filtered series. Let's look at the output. So you can see here that the filtered series, this is the output which is greater than 2, which is 3, 4, and 5. Next up, we have in the next code here, what we're trying to do is we are going to create a series with custom indexes. So if you see here earlier, there are index numbers which starts from 0. You can see the original series, it starts from 0 and it goes on, it's going to increment with a step of 1. But here what I want to do is I want to create a series with custom index, saying that the index should be according, shouldn't be the constant or the standard one, which is 0, 1, 2, 3, but rather I would like to change it. So in that case, what I'm going to do is I have to create I'm going to create a new series. Like for example, here, this is custom index series variable. And in this variable, I'm going to store a series. Okay, so you can see here pd.series, and instead of giving data for the series, I'm going to just pass the variable name data, which holds a list. Okay, whenever it's inside a square bracket, it is denoted as a list. Then here I'm going to mention the index, okay, which is A, B, C, D, E. So these are the indexes. Now after that, what I'm going to do is I'm going to print this and I'm going to show it to you what the custom index series is going to have. So the custom index series, you can see here, it is going to have all the elements from data, which is 1, 2, 3, 4, and 5. But here you can see that that our index is changed to A, B, C, D, and E, right? And then again, I have just created another line. after creating another line here, so basically everyone, what we have tried to do here is we have tried to create a new series, okay, using the same data, but we are using custom index, okay. The custom index here is A to E, right? So the series with the custom index is then printed here using print custom underscore index underscore series. Last one here is that we're going to access elements using the custom index, okay. So how can you access them? You have to give the name of your index, okay. So basically the index here, let's say I have my own custom index created and I want to access a specific element. All you have to do is you have to give the name of the variable, okay, that stores your series. So what stores my series is custom index series, and then I'm going to use my square bracket to basically access a specific element. So here, instead of giving an index number, it has custom indexes. So I'm going to give C. So when I'm going to give C here, you can see that the number 3 will be printed. You can see here, number 3 will be printed. Make sure you do not leave these single quotes or double quotes, okay? Because these are strings. If you're just going to give C, it's going to throw you an error, okay? So make sure you're giving a double quote or a single quote. Lastly, here, what we're going to do is we're gonna apply a function to a series. So what is a function, everyone? So lambda is a anonymous function, meaning that you don't have to give a specific function name. You don't have to call it. All you have to do is you have to give a keyword which is called as lambda, then give the number of variables that you are going to use in this particular equation, and the equation can be defined after this colon. You can have only one single equation, you can have multiple variables, and these lambda functions are used whenever you have a single line function, okay. Now here what we're going to do is we're going to apply a function, okay. We're going to use a lambda function. Lambda function here is going to be applied to cube each element of your original series, okay, and then we're going to store the result in cube series variable, right? So for that you have to use the function apply, and then in these parentheses give lambda keyword, give the variable x. So here x will is going to hold each and every element from your series, okay. And then after that, what we are going to do is we are going to just pass all of these elements. After passing all of these elements, so everyone, you can see I've given series dot apply. So here you can see that series is going to store the series that is created using panda, and then applying this lambda. So when I'm going to apply this lambda, each and every element is going to be cubed, okay, and you're going to get the result. And it is going to be stored in cubed series. So everyone, this is our output. I hope everyone is clear with how you can import pandas and display the series, access elements, perform operation on it, filter them, create series with custom indexes, and also apply function to it. So everyone, next step here, what we're going to do. Another thing is that there is a constantly D type int64. So this term here, okay, basically refers to the data type. Okay, the data type of the element within the series. So int64 here stands for 64-bit integer, right? So D type basically means data type, okay, which tells you what type of data that elements in the series have. In our case, it is integer, right? And then the int64, okay, it specifies the subtype of the integer data type. So when I say 64, it basically refers to the number of bits which has been allocated to each integer, okay. So in a 64-bit integer, each integer value is represented using 64 bits of memory, which allows which is allowing for a wide range of integer values to be stored. Okay, so when you see these type int64, all you need to know is that your series has elements of 64-bit integer value. Next up, so this is our first Python file. We're done with this. Next up, what we're going to do is we're going to be looking at data frames. Okay, so let's understand data frames. So we spoke about data frames, right? So now let's understand them. So firstly, the first line here, it is import pandas. Okay, so we're going to import pandas library, give it allies, basically renaming it to PD so that it can just be easier to refer to throughout your script. Next, what we are going to do here is we have created a data frame from dictionary. So everyone, just to throw some light on what is a dictionary. So dictionary is one of the built-in data types, everyone. The other data types in Python are list, tuples, set, and dictionary is one more. So it's a inbuilt dictionary, meaning that you don't have to call any function, call any methods, you don't have to import anything. You can just use multiple different methods. And dictionaries are, they do not allow duplicate keys, they allow duplicate values, they are represented using key value pairs. So now let's look at how a dictionary is denoted. Okay, so firstly I'm going to create a variable which is called as data, given assigning operator, meaning we're going to use an equal symbol. And then after that, what we're going to do is whenever we're creating a dictionary, all we have to do is we have to make sure that we are going to give curly braces. Okay, curly braces are denoted for two different data structures, inbuilt data structures, which is dictionary and sets. How do you differentiate? You're going to have a key and a value pair. You're going to have a colon that is going to separate both of them. So now here I have a key which is called as name, and I have three different names here, which is Alice, Bob, and Charlie. And then I have an age. I have three different ages which are integers, then city, and three different cities here. Right now, after this, what I'm going to do is once so to create a data frame, firstly we have created this dictionary. Okay, and after that I'm going to create another variable which is called as df, and I'm going to say equals pd, which is the name of our library, dot data frame. And then I'm going to pass my dictionary inside it. So here basically a pandas data frame has been created, and it is stored in df. Okay, it is created using our dictionary. Okay, so each key value pair in the dictionary will become a column in the data frame. So the keys that you see here, okay, they're going to become column names. So name, age, and city is going to be the column name. And the values here is going to become the data inside these columns. So name, age, city is columns, and these are all data inside it. Now let's look at our original data frame. So firstly, we're going to display the data frame. Okay, the first message we're going to print is original data frame. So let's run this code. So you can see here that my first output original data frame, which is a print statement. And then you can see your name, age, and city, which are keys, are going to act as column names. And these are all values associated with it, right? Next up, what we're going to do is after printing it, we're going to add a new column, which is named as occupation. And then the data inside this column is going to be engineer, doctor, and artist. Okay, values, these are all values. Okay, now how can you do that? So all you have to do is you have to just, here you can see, you have to just give the name of the variable that is actually storing your data frame. And then after that, you have to give a key, which is going to act as a column name. And then you have to give an equal symbol. And then here we are going to give the values, which is engineer, doctor, and artist. Next up, what we're going to do is we are going to apply a function to a column. Now, how can you do that? Okay, so to apply a function, okay, to a column, you have to always use the apply function firstly, and then you have to use lambda function. Now, before that, you can see df is the data frame, okay, where the data frame is stored. It is a variable. So here, the lambda function is applied to the age column, okay. So to apply that, all you have to do is you have to say df, which is data frame, and then a variable that holds the data frame. And then after that, I am going to give the name of my column as a key. And then after that, I'm going to say df age dot apply. And then in my lambda function, I'm going to give x plus 1, meaning that all the age has to be incremented by 1. Okay. Next, after that, after incrementing, so this is how you apply a function to your column. Next, I'm going to filter some data. What am I going to do here is I'm going to say young underscore people equals df, and then df age less than 30. So Here what we're going to do is we're going to modify our original data frame. Okay, after modifying our original data frame, I am going to filter out a few people. Okay, what I'm going to do is I'm basically going to filter out everyone who is less than 30. Okay, like for example, here you can see what I've done is I have modified. Okay, I have modified young people. Okay, so this new data frame, okay, young people is another data frame. You need to think of it as another data frame. It is being created by filtering rows where each column is less than 30. Okay, anyone less than 30, right? Now after that what we are going to do is we are so everyone, all of please remember that Python works sequentially, meaning that it is going to complete all of these different all of these different tasks sequentially, and it is going to display them. Firstly, let's look at the modified data frame. Okay, let's look at df. So in this df, what is going to happen is that to df, you have made two changes. Okay, firstly, I have added a new column, and then I have added three other values inside it. I have incremented the age of everyone by one. Okay, so now when we are going to print it, you can see the modified data frame is going to also have occupation along with name, age, city, and then you can see the ages. Everything is incremented by one. 25 is going to become 26. 30 is going to become 31, 35 is going to become 36, right? Next up, what we are going to do is we are going to display the data frame. Now you can selectively, display the data frame. Okay, you can modify the data frame and print it. What you can do is you can include only the columns that you want, right? Now for that, here you can see that I have given name and occupation as two different columns that I want to see. So you can see data frame with new columns, and then I have just given name and occupation. So you can see it's going to have all the names and it's going to have all the occupation. Let's say I wanted another column, okay, comma, city. Let's run this. So you can see here that in data frame with new column, okay, we have name, occupation, and city, name, occupation, and city. All right, so you can make the modifications if you want. Next step is the filtered data. So you remember that, we created a data frame just for the young people, okay? Age less than 30 should be stored inside the variable young people. So you can see that our output here is only 26 because everyone else is above 30. So young people is only one member, which is Alice. And lastly here, what do we have is we have another function, okay, which is describe. So the statistical information for the data frame is printed using a particular function which is called as describe. Okay, so this describe function, what it does, it's going to provide you with a summary, statistics. So now what is a summary statistics? Is going to provide you count, mean, standard deviation, minimum 25%, 50%, 75%, and max for the numeric, columns. Now let's look at this. So you can see here that the statistical information, the count is age is 3, mean is 31.0, standard deviation is 5, the minimum value is 26, and then the 25%, 50%, 75%, and the max value is also displayed here. So everyone, this is an important function which is described, okay, to provide a summary statistic of your entire information. So next up, I hope everyone is clear with this. If anyone has any doubts, please do let me know. All right. So now everyone, we're going to move ahead to our next topic, which is pandas accessing and modifying. Okay. So now that we know how to create a series and how to create a data frame, let's understand how you can access as well as modify them. Okay, so firstly here, okay, I'm going to use a very similar, data frame, which is Alice, Bob, Charlie, where we have created a dictionary. Then, we have already looked at this example. All right, just give me a moment, everyone. All right, thank you everyone for your patience. So now here what we're going to do is we are going to try and access as well as modify the data frame. So firstly here, what we're going to do is we have imported pandas, renamed it to PD, and then after that we have created a data frame using the dictionary. After that, how we are going to do that is we're going to say pd.data frame, then pass the dictionary inside it. Now, next we are going to print this data frame. Let's look at the output of this data frame. You can see this is the original data frame here. Next, after this, what we're going to do is we want to access a specific column. Okay. So I want to just access the name column and then I want to print it. Okay, so a specific column here, we are just going to use name. So how you can extract one specific column is you have to give a variable name underscore column equals, and then here I'm going to say df, which is the variable that stores the data frame, and then I'm going to give the name of the column, which is name, and then I'm going to print it. Let's run this and see the output. So you can see here, this is just the name column, which is Alice, Bob, Charlie. And you can also see that it is of the data type object. Next up, after this, okay, after accessing the data frame and also, accessing one specific column, you can access more than one column also. Next, what we are going to do is we're going to use another function which is called as ilog, which is integer location based indexing. Okay, so ilog stands for integer location based indexing. So you want to access a specific row using ilog. Okay, so here what we're going to do is I am just going to give the variable which is called a second row. You can give any name you want, then give the name of the data frame, a variable that is holding the data frame dot ilog, and then here we are going to pass integer location based indexing. So firstly what I'm going to do here is I'm going to just give one. Okay, and then so you know that it or the row number starts from 0. Okay, so always remember, so here inside this you have to give the row index. Okay, now what a row index, also remember that row index starts from 0. Now I want to look at, so when we're going to look at this, okay, so you can see here that our second row, okay, we're going to be accessing the second row here because the first row, as you saw, is going to be Alice, 25 and New York because it is at index 0. It always starts with index 0. So at index 1, we have Bob, 30 and San Francisco. So you can see here that our output is going to be Bob, 30 and San Francisco because we are going to access index 1. Now let's try to access index 0. So your output needs to be the very first row, which is Alice, 25 and New York. So running it, you can see here the output is Alice, 25 and New York. Okay, so here I'm just going to change this to 1 because here we're trying to access the second row. Next, after this, okay, we're going to be looking at another function which is called as LOC. Okay, if you want to print a specific element, you can print it using log. Okay, using location. Now here again, we're going to use another variable where we're going to store the value. Then we're going to use the data frame, then pass the log function. And then after that, we're going to give an index number. Okay, 0 and then name. right? So when you give 0 and just name, okay, you can see here that in the name column at the index number 0, we have Alice. Index number 2, we have Bob. Index number 1, we have Bob. Index number 2, you have Charlie. Hence, age of Bob, we have dot log here. So here what we're going to do, at index 1, we have Bob. So the output, the output here is going to be Bob. You can see that name is Alice. Okay. Uh, yes. One second, everyone. Let me just change this to 2. Okay. Changing this to 2. Name at index 2 in name column. Okay, it was just getting a little bit confusing with all the numbers here. Yes, so running it back again. So you can see here that name at index 2 in column name is, in name column is Charlie. Okay, you can see that the output is Charlie here, right? Next up, what we're going to do is we're going to access a specific, element using lock again. Okay, so this is the same function, everyone. Okay, here we are just using the column name, and here we're using the column age. Okay, so age here, the output is going to be 30 because we're trying to access the first index number, and here we're going to specify the column name. Okay, so you can think of the syntax as data frame dot log, and then you are going to give a square bracket. In the square bracket, you're going to give the index number, comma, the column name, column name. Okay, and make sure the column name is in single or double quotes. Yes. So next here, the output is 30 for Bob. The age was 30. Next up here, modifying data. Now, modifying data here, basically, how can you modify any data? It's by adding or removing something, right? So here, what we're going to do is we're just going to add another column, okay, into our data frame. So to add anything, you have to just give df. So it's very similar to a dictionary where, you just give the name of the dictionary, pass the key, and then pass the values for it. So here what we're going to do, this is our column name, and this is the data associated with it. Okay. Also, how you can modify something is using a particular function which is called as at. Okay, so whenever you want to modify something, you have to just give the name of the data frame, give a dot, give at, and then give the index number, okay, and then give the name of the column and then modify it. So here I want to modify the age from 25 to let's say 90. Okay, so then what I will do is when I'm going to print it, not only I'll have a new column, but I will also, but I have also modified this age. So let's run this. You can see here that age is modified to 90, and even the occupation column and the data has been added. So everyone, this is Pandas accessing and modifying a file here. Next up, what we're going to do is we're going to be looking at the pandas function. So let's navigate back to our PDF here. Yes. So everyone, the next step that we are going to look at, or the next topic that we're going to be looking at, is called as important functions of pandas. So let's dive into what are the different functions apart from the basic ones that we have just looked at. So the first function that we are going to start off with, okay, is the unique function. Now, what is a unique function? So a unique function is a function that is used to obtain all unique values in a particular column of the Panda series. So what it does is it is going to return an array of unique elements in a series. Now, let's look at different codes and understand all of these functions. Okay, I have a code written already. that we can look at. We can understand the syntax, and we can also understand these functions and what they're going to give you the output as. Okay. Now, let's start off so with pandas function. So the first thing here, okay, so the very first thing that you're supposed to do is you are supposed to import the pandas library. Okay, after we have imported this pandas library, we're renaming it. So we're renaming it to PD. Alright. In the next step, what we have done is we are actually creating a data frame. So how are we creating this data frame? Using a dictionary. And we're naming this dictionary as data. After that, what we're going to do is we are going to basically convert this entire dictionary into a data frame using this particular line. So the variable name is df, and this is your assigning operator, pd.dataframe, passing the dictionary into the parentheses. And then after that, we have created our data frame here at this step. Now I'm just going to print the data frame. Okay. And here I'm just going to add a comma, df, and close the parentheses. And now here we are going to run this. So let me just run the previous cells. Okay. So here you can see that our data frame, okay, and one second, everyone, looks like I'm just going to add a space here, close the double quotes, run this again. Let me just print df. Yeah. So here this just looks much more readable. So here what we're going to do is we are going to just print our data frame, which is going to have age, names, cities, and salaries. Okay. Next, what we're going to do here. After this, so it has all of these different names, ages, cities, and salaries associated with it. So we're going to be looking at our very first function, which is called as the unique function. So what is a unique function? So this particular function is used to obtain all the values in any particular column, okay, and of your panda series, and it is going to return you a unique element in series. Like for example here, okay, we have created our data frame. Okay, after creating our data frame, I am going to create another variable which is called as unique underscore cities. And then after giving my equal symbol here, I'm going to use my data frame df, and then I'm going to pass the name of a column that I want to check for. Okay, so here I'm going to be looking at the cities. Okay, so you can see here all of them have different city names. Let me just try to make one of them the same. I'm going to change Chicago to New York just to understand this function, New York. Now, everyone, as you can see here, we have New York twice. So I'm going to pass my column city, and then I'm going to check for the unique values. Okay, when I am going to run this, you can see what will happen. Okay, that when I'm going to pass the unique function, only the unique values will be returned and the duplicate values will be ignored. Okay, and let's run this code. And you can see here that my output is New York, San Francisco, Los Angeles, and Boston. And it does not have New York twice. It's just going to give you unique values. Next, we have another function which is called as value count function. So what is a value count function? So first of all, let me just, okay. So the value count function, it has a syntax of series dot value underscore counts, and or And here we have normalize equals false by default. Okay, so this is the syntax, everyone. Okay, or you can even have data frame. So this is going to be the same data frame. We're using a data frame in this case. You can even use it for series. Data frame dot value count, and by default it's false. So normalize equals false means that if this function is false, it is going to provide count of unique values. Okay, how many ever unique values are there in your column? Okay, let's say if it is true. Okay, if it is true, then it is going to return the frequency of your unique values, how many times a specific value was repeated. Okay, now let's look at both of these functions. Okay, when normalize is false and when normalize is true. So here we have created a variable which is called as value underscore counts underscore age equals df, and then the name of the column that we're going to pass is age, and then we are going to use our value underscore counts function, and then this is a print statement. Okay, value count for ages, and then we are going to print value underscore count underscore age here. So here what is going to happen is that you can see that I have, okay, the value, we have 25, 35, 28, and 22. So it is going to, what it's going to do is it's going to provide the count of your unique values. Okay, and you can see here, okay, let's say for example, I am going to change this to 29, which is all different. Okay, you will see that instead of 0.4, everything is going to become 0.2, 0.2, and 0.2. Okay, you can see here, you can see here that each of these counts are repeated just once. Okay, so you can see the count of all of these unique values. 25 is once, 29 is 1, 35 is 1, 28 is 1, and 22 is 1. Now, changing it back to 25. Okay, now you can see that the value, okay, count for age 25 is changed to twice. Okay, and in the frequency section, okay, here what we have done is instead of keeping this as false, we have changed this to true. Okay, value count, just to see the difference. Okay, whenever you change it, it is going to return you relative frequency. So the relative frequency of 25 is 0.4, 35 is 0.2, 28 is 0.2, and 22 is zero point 0.2. And it is also going to return you the data type. In first case, when normalize is false, it is integers, and when normalize is true, because it is returning you frequencies, it is in the float data type. In the next function here, we have the next function which is called as the column. Okay, so what is a column function? The column function, it has syntax of data frame dot columns. So this function is going to return you the list of column names in your pandas data series. Okay, so like for example here, okay, so we have column underscore list is equal to df dot column. So this is going to return you all the different columns present inside this data frame df. Okay, so you can see it is name, age, city, salary, and the data type is object. Next up here, we have another function which is called as the apply function. So now, again, you have to give the data frame and dot apply map, and then inside the parentheses, you have to provide a function. Okay, so your function can have one single expression, but in this single expression, you can have like, you can have an if-else statement also. So let's explain what is happening here. So in this particular example, what we're trying to do is that the apply map function, okay, it applies a function that accepts as well as return a scalar to every element of your data frame. Okay, it is going to use it is used for data, it is actually going to use element wise operation on your entire data frame. Like for example, let's say here what we are trying to do is we're trying to apply a specific function to your entire data frame. Okay, what we are going to do is I am going to have a function, and this is a one-line function, anonymous function lambda. You're going to have one single variable which is going to hold each and every element inside your data frame. Then here I'm going to check, okay, if else statement. I'm going to check if the data type of my column is a string. If it is a string, okay, only when it is a string, I'm going to convert it into uppercase, okay, dot upper. Else, I'm just going to leave it as it is, okay, and I'm going to apply it to my entire data frame. So you can see here in my output, all of these string values have been changed to uppercase, whereas the numbers are going to remain as it is because they are not of the data type string, okay. Next, after that, we have another function which is called as the sort value function. So what is a sort value function? So the sort value function helps you sort your data. Okay. Now, for example, there are three different parameters. So let me just add this. Okay. So this is how the syntax looks like. It is going to have data frame dot sort and underscore values, and then here I'm going to give by. This is one parameter. There is ascending and there is in place. Okay, three different parameters. Let's understand what all of these are. Okay, so firstly we have a variable which is called as sorted underscore df, and then this sorted underscore df is going to hold it's going to hold the data frame, and then we're going to pass a function which is sorted underscore values. Now what does by mean? Okay, by means the column name to sort. Okay, so firstly you're going to specify the data frame, then what column you want to sort. So the column that I want to sort is age. And then after that, what I'm going to do is I'm also going to provide the order in which it has to be sorted, ascending or descending. So whenever it is true, okay, the data frame will be sorted in an ascending order. When it is false, it is going to be ascended in a descending order. So you can see I've given false and it is in a descending order. You can see the age is 35, 30. Okay, it's been sorted in this way. Then after that, I'm just going to print it. So you can see that it has been sorted 35, 30, 28, and 22. Let's say, for example, I want to sort salaries. Salary, and then I'm just going to run this. So you can see here, okay, that it has changed. And here we have, it's been sorted. 1 second, everyone. I think I've just scroll down here. Yes, let me just run this code again. Yeah, perfect. So you can see here it's been sorted according to salaries. It's 90,000, 80,000, 75, 60, and 55,000. And the order is descending here. If you're going to change it to false, it's going to be in an ascending order. Running it again, and you can see here it starts with 55, 60, 75, 80, and 90,000. Right? Now, after this, what we're going to do is we are going to look at, so this is how you can sort values. Okay, this is the sort value function, and you can apply it into your data frames. Okay, next up we also have another so also there is another parameter here which is called as in place. Now what is in place? So whenever in place is true, okay, the sorting will be done in your original data set. Okay, when it is false, the sorting will not override your original data set, right? So you can decide if you want to do that. Next up, we have another, function which is called as group by function. So what is a group by function? So group by function, it has a syntax. Let me just add it. So here we are going to have the syntax. So the syntax, so everyone's syntax is very important whenever you're working with functions as well as methods. So here we're going to give data frame dot group by, and then the only parameter you're going to have is by, and then you have to mention the name of the column. Right? Now, what we're going to do is the group by function is used to split the data into several groups, okay, based on your criteria. So it provides a mapping of labels, to group names, and can be used to, create a pivot table. Now, for example, here, you can use each here what we have done is we have just grouped the entire column with respect to cities. Okay, so what I can do is I am going to have here, I'm going to group it via cities. Okay, now let's say for example, yes. So grouping it by cities, okay, I am going to give our data frame name, group by function, and by cities, and we are going to display the group information. Now, how are we going to display it? Is we are going to use our for loop. Okay, in the for loop, we're going to have two iterating variables, and then we're going to pass this group by cities. Let me just print it and show it to you how it will be if you try to directly print it. It's going to give you the object address. Let me just anyway show it to you. And why we're using the for loop. So you can see here, when I've given the first print statement, it's going to give me the object address where it is stored. Okay. So to display all the group information, you always have to use a looping statement, okay, like for loop. So I'm going to have city and then I'm going to have a group. Okay, so like for example, whichever city you have, okay, it's going to just club all of them together. Like for example, here I have New York twice. So under the New York City, you're going to have, okay, you're going to have Alice as well as David. Okay, and everyone else is going to be individually. So here under group by cities is going to be our iterating sequence, and then this is our first way, iterating variable, and this is our second iterating variable. Now, city is going to be Boston, and then I'm going to display all the different, users in Boston, and then in Los Angeles, then in New York, and then in San Francisco. So, using the for loop, it can iterate over the entire group by cities sequence, and it can display it one by one. So everyone, this is about pandas functions. So I hope everyone was able to understand the different functions in pandas. So everyone, we are done with this particular functions in pandas. Now we have completed the demo. We're going to be looking at how you can load the data and manipulate using pandas. Okay, so firstly, let's understand loading data in pandas. Okay, so pandas, it provides a specific function which is called as pandas.read. Okay, pandas.read Excel, pandas.read SQL. Okay, so all of these different functions, it helps you read data from different types of files like the SUV, the CSV file, the Excel sheets, the SQL databases, and other different databases. So what you can do is you can actually import parameters such as, specifying delimiters, and you can actually handle the missing values, and you can even set data types. You can actually customize, all of this during data import to ensure you have accurate loading. Also, what you can do is data exploration. When I say data exploration, you have viewing data. So you can view data using functions like head, tail, sample. You can actually allow users to view the beginning, the end, or even the random samples of, your data set. You can also use another function which is called as info. So there's a function which is called as info, which is going to provide you like a summary of the data set, including the data types and even the non-null counts. You're going to use describe, okay, which helps you with all the statistical insights into your numerical columns. Also, what you can do is you can do data selection. Basically, you can cleanse your data, you can transform your data. Okay, so functions like drop, final, and fill NA, replace, they all help you to clean as well as transform your data. So operations can be applied to entire columns using, functions like apply and even map. You also using pandas, what you can do is you can provide methods like, drop duplicates to handle any missing values. You can use fill, and using this you can basically fill the missing values as well as duplicates. And lastly, your grouping and aggregation. So you can use the group by functions. So all of these group by functions are used to group data based on certain, categories or even columns. You can perform aggregations like sum, mean, count, and you can also use merging and joining data. So you can basically use merge and concat. Okay, both of them are used to combine multiple, data frames based on common columns as well as indices. You can use a basic panda, visualizations like matplotlib for basic data visualization, functions like plot, hist, that basically allow you to create like a simple visualization for your data. You can also save the data in different file formats. Like the data can be exported to various formats such as CSV file, Excel file, or SQL file. You can use these functions which is to CSV, to Excel, to SQL, etc. Yeah, we have loading data manipulation using pandas. There's another file. Okay, so right now, all of it that we just discussed, okay, is just put in a form of a Python file here that we can look into and understand. Okay, let me just quickly share my screen and let's understand this entire, you know, topic that I just discussed. Yes. So the next topic that we're going to be looking at is pandas data loading and manipulation. So everyone here, instead of loading a CSV file, I'm going to use a URL. Okay. So firstly, just give me a minute. Let me just display this URL to you. Just going to copy it, paste it here. Right. Okay. So everyone, this is a data set. Okay. Now, firstly, the first thing that you're supposed to do is we have to import pandas. Okay, the very important step. So after importing pandas, renaming it as PD, okay, the next thing that we are going to do is we are going to create another variable which is going to hold our data. Okay, so this data is it's actually stored on a GitHub link. Okay, so you can try to access it here. It is a data set. Now here you have to add any URL. If you're using any URL, please make sure that you are giving double quotes or single quotes. Now we are going to use read underscore CSV function, okay, from pandas, so that you can read the data from a CSV file. Okay, but this CSV file, it is being hosted on a URL, right? So that is why I have given it, I have given the URL name here and then added this variable name here. But if you just have a direct CSV file in your directory, it has to be in your directory, or if it is somewhere else, you have to mention the path, okay, the absolute path of that file. And here what we are going to do is, after giving this function, the next step, okay, that we're going to do here is so everyone, please remember that we have this particular function read underscore CSV file. So this read underscore CSV file is helping you read the data, okay, from the CSV file hosted on a URL. Now the data set, if you see, okay, it is related to the Titanic data set. Okay, so after that, what we are going to do is the resulting data frame, whatever data frame that we have given here, okay, it is going to be stored in a variable which is called as Titanic underscore df. Right. The next step that we're going to do is we're going to display the first few rows of our data frame. How can we display this? Okay, how can we display this first few rows? There is a function. So this particular function is called as the head function. So head function, okay, you're going to use the variable name, which is Titanic underscore df, and then after that, we're going to use dot head. So dot head is another function that is going to help you to display the first few rows. Okay, by default, it is 5 rows, okay, of the data frame. So this helps in getting a look of the data that you're working with, right? So when you're going to run this, okay, let me just run this again. Now, you can see here, everyone, that my dot head function, this is our output, which is that I am able to see the first 5 rows, okay, the first 5 rows here. You can see here there is passenger ID survived, okay, and it goes on to embarked, right? So you can see here it is until embarked, and all of these rows are displayed here. Okay, so the first 5 rows are available here. Next, after this, what we are going to do is, after we have looked at the first 5 rows, the next function, okay, we're going to be looking at a few basic, data frame information. You want to get some basic data frame information. What you do is you use this function which is called as dot info. Okay, this is an important function. Using dot info, always remember that we are constantly using Titanic dot underscore df, that is going to hold your CSV file, okay, entire CSV file. And here we are going to give Titanic underscore df dot info. So info function will provide you with like a basic information about the data frame, like including data types of each of your column, the number of non-null values. This is very important to understand the structure of your data set. Sometimes we have very large data set, and this is very crucial. This particular function is very crucial so that you can have an idea about what kind of data set you're working with. Okay, and you can see here it will give you the data of different columns, non-null count, and even the data type. Next up, we have another, function where we are trying to get a summary of the statistics of the numerical value, columns. So to get it, what you need to do is you have to just give dot describe. We previously saw this when we were even working with NumPy. Okay, so when you give dot describe, what it does, it gives you count, mean, standard deviation, minimum value, 25%, 50%, 75, and the maximum value for all of your numerical columns. Okay, this is applies only to the numerical columns. Okay, so you can see here, this is our output here. Next up, we have filter. How we are looking at how you can filter your data. Okay, so whenever you want to filter the data frame, okay, you need to include only the rows. Okay, like for example here, okay, I want to filter the data and I want to get just the female passengers. Okay, so to get the female passengers, I'm going to give the name Titanic underscore df, and then in my square bracket, I'm going to mention the column which is sex. Okay, and I'm going to say that I want to just look at the female passengers. Okay, so this double equal symbol is nothing but a comparison operator. Okay, it is a double equal, helps you compare. Okay, compare, so it can either be male or female. Okay, whenever it is female, only then it will be stored inside female underscore passenger. If it is anything apart from female, it will not be stored in female underscore passenger. So here, what we're going to do is, because we have a very large data set, we're going to just pass head. Okay, we're going to say female passengers dot head, and the first five female passenger data will be displayed to us. Okay, you can see here, this is the data. So you can see here the sex is female, 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 and female. Now let's say you're like, no, I want to look at the other gender, which is male. So I'm just going to change it from female to male. Now we will get the data set of only the male passengers. Okay, so you can see here the sex here is male. Okay, and you're going to get the first 5 rows using the head function. Next up here, we have a grouping. We're going to be looking at grouping and aggregation. Now, grouping and aggregation here. So we're going to use the group by function. Everyone, I hope you all remember the group by function. Okay, so using the group by function. So what is a group by function? So group by function is used to group the data by a specific column, and then you can even apply a specific function to it, like mean. Okay, like for example here, if you see grouping and aggregation, I have created a variable which is called as class-wise underscore survival rate. And then we are passing a Titanic underscore df, which is going to hold the entire data. And we're going to group by T class. Okay, P class. And then the survived, and the output needs to be survived, and then we're trying to find the mean of it. So here we're trying to display the class-wise survival rate. Okay, so to get the class-wise survival rate, what we're going to do is we're going to find the mean of each. So you can see here the class-wise survival rate is 0. 0.29, and then it is 0.47, and then it is 0.24. So this will provide like the class-wise survival rate of each. And so here you can see we also had another column which was called as survived. Okay, you can see here it is there's another one which is called as survived. So based on the data, it is going to calculate it, okay, according to the classes. So you can see here the class is 3, 1, or it is 2. So it is first, second, and third. Okay, based on all of these classes, it is going to give you the survived mean value. So mean here, so basically an average value here. Next up, okay, so next up we have creating a new column which is based on conditions. Okay, now we have we have another column which is called as age. So you see here there's another column which is called as age. Now what I want to do is I want to create another column which is called as is child, and the condition is that if the age is less than 18, you are supposed to add those data inside this column is child. Okay, now if you see here, right, what happens is that it is going to check, okay, if it is a child or not. Okay, so because this is a condition is always equated to either true or false, correct? Now, so please remember that whenever you give such things, okay, you're either going to get true or false. Later on, if you want to see it, see the value, you need to map them, okay? That we will see later on. So here, Titanic underscore DF is child, and then we're going to pass the Titanic, underscore data frame data, and then we're going to check for the age, if it is less than 18 or not. So you can see here, okay, data frame is child column will be created. Okay, we're going to be looking at the first 5, rows. So you have passenger ID, survived, P class, you have name, sex, age, you have ticket, fare, cabin, embarked, is child. So you can see there wasn't any is child column earlier, but using our, here what we have done is we have just created a new column. Okay, and then instead of giving values, we are passing a condition. So you can see here everything here is false. Okay, because the age is greater than 22. So what you can do is what you can also do, just to change it and just for better understanding, is adult. Okay, and then here age is greater than 18. Okay, now let's see the output. So you can see here, yeah. So you can see here that the output is adult is true for everyone because the age is greater than 18. Okay. But anyway, I'm just going to, change it to whatever it was, which is for understanding. Now, next up here, we have another function. Okay. So our very last function here is that you need to save the modified data frame to a new CSV file. So how can you do that? So to do that, okay, you have to just use to underscore CSV. Okay, and then you have to also mention the name you want to save it as. Okay, so I want to save it as Titanic underscore modified dot CSV. And then I have also given index. So the index here I have given it as false. Okay, so the false parameter that I have given is basically going to prevent saving the rows indices in the CSV file. Okay, and here Titanic modified CSV, it is going to save the modified file to a new CSV file. Okay, and the name is given here. So if you want to save it as an Excel file, you can give 2 underscore Excel or 2 underscore JSON, whatever type of file you want, it can be done. And then you can see that I have a print statement. It says that modified data frame is saved to Titanic underscore modified.csv file. So you will find it in your directory once you have saved it. So everyone, this brings us to the end of this particular file, navigating back to our last slide for this particular module. So there are a few key takeaways after completing both of these very important libraries. Okay, firstly we will go through NumPy and then we will be looking at pandas. So NumPy has efficient arrays, meaning that NumPy provides a very powerful object which is numpy.array that is more memory friendly and even faster than our standard Python built-in data structure, which is a list for numerical operations. Also, it has a multi-dimensional support. Okay, when I say multi-dimensional support, so NumPy supports multi-dimensional arrays, not only a single dimensional, also a two-dimensional as well as a three-dimensional array. And it is also essential for numerical computation. It helps in broadcasting, meaning that it has a very powerful feature, okay, which is called as broadcasting, that allows operations on arrays of different shapes and sizes, making it much more flexible for element-wise operation. Also, it has math functions. So NumPy offers a wide range of mathematical operations for array operations, including basic arithmetic, trigonometry, and even exponential and even logarithmic functions. Also, NumPy includes functions, that generate random numbers, which is very useful for various applications like simulations as well as statistical analysis. It includes indexing as well as slicing. So NumPy provides effective indexing and slicing capabilities, which enables easy extraction as well as multiplication, manipulation of data within the array. And it is NumPy arrays are actually more memory efficient due to their fixed, types, allowing for better performance, in terms of storage and even computation. Lastly, NumPy is widely used and, integrated with other, scientific computing libraries, making it like a fundamental tool for tasks like linear algebra as well as signal processing. Next up, we have pandas. So about pandas, introduces primary data structures, which is series as well as data frames. So these both data frames, they provide a very powerful as well as a flexible way to handle as well as manipulate structured data. Also, pandas excel in data manipulation, task, which allows for operations like filtering, sorting, grouping, and even merging data sets. Also, Panda has a very excellent support for time series data, specialized data frames and even functions for time-based indexing as well as analysis. And Pandas, it supports, it actually supports multiple it has a flexibility of input and output, meaning that it supports a variety of input and output formats, like making it easy for you to read as well as write into various sources like CSV, Excel, databases, and more. Also, grouping and aggregation. So Pandas enables grouping of data based on specified criteria and even performing aggregation, facilitating summary statistics and even analysis on grouped data. And Pandas also provides, data exploration for quick data exploration using functions like, we have head, tail, describe, etc. Also, handling categorical data, meaning Pandas effectively, handles categorical data, enabling better memory usage and even providing functionalities for encoding, decoding, and analysis of your, categorical variables. And lastly, integration with NumPy. So Pandas is like, it's actually built on top of NumPy, which allows seamless integration and even even, because of the seamless integration between both of these libraries, Pandas data structure can be used in conjunction with NumPy functions. So they can be used together seamlessly. So everyone, these are a few takeaways of NumPy and Pandas. So we have completed like the introduction of NumPys and Pandas, and this brings us to the end of this module. I would like to thank you all for completing this video. We will we are going to end this video right now, and then we're going to start off with our next module. So thank you everyone, and if anyone has any questions, you all can please let me know.